Hi, Mr. Richards here. Today's algebra lesson, our last in Chapter 8, is called Perfect Squares. Our objectives are to factor perfect square trinomials and to solve equations involving perfect squares. And you can see in our key concept box up here on how we're going to be factoring these perfect square trinomials. If we have a squared plus 2ab plus b squared, this will simply factor into a plus b squared. Or if we have a squared minus 2ab plus b squared, this will factor into a minus b squared. And you can see in our examples, x squared plus 8x plus 16 factored into x plus 4 squared, and x squared minus 6x plus 9 factored into x minus 3 squared. And so we're going to go through a series of steps to check whether or not we'll be able to apply this concept to our trinomials today. In our first question, we have 25x squared minus 30x plus 9. And we need to determine whether each trinomial is a perfect square trinomial. Write yes or no. If it is a perfect square, factor it. Well, we have, again, 25x squared minus 30x plus 9. And we're first asked, is the first term a perfect square? Well, this first term here is 25x squared. Now, is it a perfect square? Can I take the square root of that and end up with a number? Sure. Square root of 25 is 5. The square root of x squared is just x. So this is really equal to 5x squared. What about the last term? Well, my last term is 9. Is that a perfect square? Yeah, because the square root of 9 is simply 3 squared. Now, when it asks this third question, is the middle term equal to 2 times 5x times 3? What we need to look at here in our rules is 2ab. And what this really is 2 times a times b, where the 5x is my a and the 3 is my b. That's where it's coming from. 2 times that 5x times that 3. Well, if you multiply those together, 2 times 5 is 10 times 3 is 30, and I have x. So yes, that part is true as well. So for all three questions so far, I have yes, yes, and lastly, yes. So what this means is 25x squared minus 30x plus 9 is a perfect square trinomial. Now, if I rewrite this using the a squared minus 2ab plus b squared, I would have 5x squared minus 2 times that 5x times 3 plus 3 squared. And that factors using our pattern into 5x minus 3 squared. And that is my solution. Let's see if we can do this for our next example. 49y squared plus 42y plus 36. So is our first term a perfect square? Well, 49y squared, I can take the square root of both of those. The square root of 49 is 7. The square root of y squared is y. So yes, the first term is a perfect square. Now what about my last term, the 36? Well, I could rewrite 36 as the square root of 36, which is 6 squared, so yes. And now, again, for the last term, we're looking to see if this is going to be equal to 2 times a times b. And our a is the 7y, and the b is the 6. Well, if we multiplied those together, 7 times 6 is 42, times 2 is 84, times that y. Well, 84y is not the same as 42y, so this answer is no. And since it's not a perfect square trinomial, we do not need to factor it. So all we need to do to answer this question is to say 49y squared plus 42y plus 36 is not a perfect square trinomial. And we can move on. In our next example, we have 49x squared plus 28x plus 4. So as our first term, 49x squared, a perfect square? Well, the square root of 49 is 7. The square root of x is, or x squared is x. And so we have 7x squared, so yes, it is. What about our last term, 4? Well, the square root of 4 is 2, and we can just write that as 2 squared, so yes, it is. And then we look to see, well, is it equal to 2 times a times b for the middle term? And that, of course, is 2 times 7x times 2, which is simply equal. 2 times 7 is 14, times 2 is 28x. And yes, it is. So I can rewrite now my 49x squared plus 28x plus 4. So yes, this is a perfect square trinomial. So I can rewrite this now as my 7x squared plus 2 times 7x times 2 plus 2 squared. And this simplifies into just the a plus b squared, so 7x plus 2 squared. And that is my factored solution for this perfect square trinomial. And we have one last example of this. Is the first term a perfect square? Well, for 9x squared, I can rewrite this as 3x squared. The last term is 16, and yes, I can write that as 4 squared. So I need to check now, is it equal to 2 times a times b? And that would be 2 times 3x times 4, which would be 2 times 3 is 6. Times 4 is 24x. And that's not what I have in my trinomial there. I have a negative 12x, so my answer is that this is not a perfect square trinomial. So here is a summary of our factoring methods. Now, when you factor, you do need to have the polynomial written as a product of prime polynomials. You want to have it so it cannot be factored anymore. And so here are the steps that you can take. You can factor out the GCF, and you can notice how the 2x got factored out there. You could check for a difference of squares or a perfect square trinomial. And then you can apply factoring patterns or factor by grouping. All the different ways that we have factored polynomials in this chapter. Now, if no pattern fits and none of this works, then it might already be a prime polynomial. Factor the polynomial if possible. If the polynomial cannot be factored, write prime. Well, our first step in factoring methods is to factor out the GCF if there is one. And here with 6x squared minus 96, there is a GCF, and that is 6. So if I factor out a 6, I'm left with x squared minus 96 divided by 6 is 16. And now we get to look at our x squared minus 16. Well, if you remember our difference of squares, we can take this x squared minus 16 and write this as x squared minus 16 is 4 squared. And now remember that the rule for this is a plus b times a minus b if you have a minus b squared. So you can factor this out. 6 times the x plus 4 times x minus 4 using the difference of squares. And that is our answer. So first, we factored out the GCF of 6, and then we looked to apply the difference of squares rules, and we did so to factor our answer. In this question, we have factored the polynomial if possible. If the polynomial cannot be factored, write prime. Our first step in our factoring methods is to factor out the GCF. Well, the GCF of 16y squared, 8y, and 15 is simply 1, so that's done. And now we want to look to see if this is a perfect square trinomial. So we need to ask ourselves, with 16y squared, can I rewrite that? Well, yes, that is 4 times y squared. What about the 15? Well, I can't do anything there. It's not a perfect square, so it is not a perfect square trinomial. So that method is out. Now this is in the form of ax squared plus bx plus c. So if I look at my 16y squared plus 8y minus 15, my a is 16, my b is 8, and my c is negative 15. So do numbers exist where I can have a product of that 16 times negative 15, which is negative 240, that result in a sum of 8? Well, 20 times negative 12 is negative 240, and that also results in a sum of 8. So I can rewrite this then as 16y squared plus 20y minus 12y minus 15, and now I can factor by grouping. So if we start off with the 16y squared plus 20y in one group, and then add that to negative 12y minus 15, I can factor out a 4y from the first, which leaves me with 4y plus 5. And then I can factor out, let's say, a negative 3 from the next one. So negative 3 times leaves me with 4y plus 5. And so I end up with now 4y minus 3 times 4y plus 5. And that is my solution. 4y minus 3 times 4y plus 5. So again, go through your steps. Look for the GCF. Look to see if it's a perfect square trinomial or difference of squares. If it's not, then look to do our other rules and see if you can factor by grouping or other methods. Now I get to solve the equation and confirm our answer is correct using a graphing calculator. We have 4x squared plus 36x equals negative 81, and we want to get this equal to 0. So we're actually going to add 81 to both sides of our equation here, which leaves me with 4x squared plus 36x plus 81 equals 0. Now there is no GCF to factor out here, so what we can do is to look to see if this is a perfect square trinomial. Can I write 4x squared as a perfect square? Well, yeah, that is 2x squared. And for the 81, that's simply 9 squared. Then I need to check, is 2 times 2x times 9 equal to 36x? Well, 2 times 2 is 4, times 9 is 36, and we have our x, so yes, it is equal to 36x. So this is a perfect square trinomial, which means I can write this as a plus b squared, which is then just 2x plus 9 squared. Well, that's going to equal 0. So I'll have 2x plus 9 times 2x plus 9 equal to 0, which means I can set the equation up. 2x plus 9 equals 0, and 2x plus 9 equals 0, but there's really no point in solving this one, so I'll just subtract 9 from both sides here, get that to cancel, left with 2x equals negative 9, divide by 2, divide by 2, and x is equal to negative 9 halves. Now to confirm your answer using a graphing calculator, we're going to use this part of the equation here, and I'll slide this up here so we can have a little more room. We have our y equals 4x squared plus 36x plus 81. And so whether you use an internet graphing calculator like Desmos.com, which is where I got these images from, or even a TI graphing calculator, it should show this. And you can see where the graph intersects the x-axis here at negative 4.5, and sure enough our answer was negative 9 halves, which is the same thing as negative 4.5, so we are good to go. What about this equation? 9x squared minus 30x plus 25 equals 0. Well, let's see if this is a perfect square trinomial. Is 9x squared a perfect square? Well, yes, because I can write that as 3x squared. Is 25 a perfect square? Yes, I can write that as 5 squared. And then I need to look at what 2ab is equal to. That would be 2 times 3x times 5. 2 times 3 is 6, times 5 is 30x, and that's matching this. So I do have a perfect square trinomial. So I can write this then as a minus b squared. So this would be 3x minus 5 squared. Now that's going to equal 0. So I have 3x minus 5 times 3x minus 5 equals 0. So we can write down our equations. 3x minus 5 equals 0 and 3x minus 5 equals 0. Add 5 to both sides. And of course, whatever you get on the left side is going to be what's on the right side for the equation. So we just need to solve the 1. We're left with 3x equals 5. Divide by 3 on both sides of the equation, and x equals a positive 5/3. Now to confirm this answer using a graphing calculator, we can use the equation y equals 9x squared minus 30x plus 25. And we'll go ahead and slide up so we have a little bit more room. Now here's the graph. And we can see where our graph crosses the x-axis 1.6667, which is the same thing as 1 2/3, which is the same thing as 5/3. So it's confirmed. Our square root property states to solve a quadratic equation in the form of x squared equals n, take the square root of each side. Okay, let's do that. We'll have the quantity b minus 7 squared equals 36. I'm going to rewrite this here just to give myself a little more room. Now, what I can do here is to take the square root of both sides. So that leaves me now with b minus 7 equals plus or minus 6. Why plus or minus 6? Well, when you think about it, a positive 6 times a positive 6 is 36, as is a negative 6 times a negative 6. That also equals a positive 36. So you need to consider both cases here, that b minus 7 could equal a positive 6, or b minus 7 could equal a negative 6. You need to consider and solve for both. So if we add 7 to both sides of our equation on the left, b is going to equal 13, or if you were to add 7 to both sides of our other equation, b is going to equal 1. So the roots are 1 and 13. Now to confirm this answer using a graphing calculator, we can say y equals the b minus 7 squared minus 36, since we can get that to equal 0, or in other words, y. And we'll move this up now to see what this looks like on a graph. And you can see where this graph crosses our x-axis, where x is 1 and x is 13, and sure enough, those are our two roots. In our next equation, x plus 9 squared equals 8. Again, we will rewrite this here. So if we take the square root of both sides, we're left with x plus 9 equals plus or minus, and let's write this as the square root of 8. Now there is a way to simplify the square root of 8. If you look at the 8, that's 4 times 2. And then you really just have the square root of 4 times the square root of 2. Well, the square root of 4 is 2 times the square root of 2. That's a way to simplify the square root of 8. So what we can write this is x plus 9 equals plus or minus 2 times the square root of 2, or 2 square roots of 2. Then, to solve, subtract 9 from both sides. This simplifies to x equals a negative 9 plus or minus 2 times the square root of 2. And believe it or not, that is your answer. To confirm this answer with the graphing calculator, we can use the equation y equals x plus 9 squared minus 8. And one last time, we'll slide this up to see what our graph looks like. And there's our graph, and we can see where it intersects at negative 11 and 8/10 and negative 6 and 8/10. And if you were to take 2 times the square root of 2, you would get about 2.8 or 2 and 8/10. So negative 9 minus 2 and 8/10 gets you to the negative 11 and 8/10. And negative 9 plus 2 and 8/10 takes you to the negative 6 and 1/10 or so. So that confirms our answer. A book falls from a shelf that is 5 feet above the floor. A model for the height h in feet of an object dropped from an initial height of h0 feet is h equals negative 16t squared plus h0, where t is the time in seconds after the object is dropped. Use this model to determine approximately how long it took for the book to reach the ground. We have our formula, h equals negative 16t squared plus our initial height h0, and we're told 5 feet above the floor, and we want to find out where it is when it's dropped at the ground. So our height is going to be 0 on the ground, equals negative 16t squared, plus our initial height of 5. Now to solve this, we're actually going to subtract 5 from both sides. This cancels out. We're left with negative 5 equals negative 16t squared. If I divide by negative 16 on both sides, I get the decimal, a positive 0.3125 equals t squared. And if I take the square root of both sides here, we're left with plus or minus 56 hundredths is about our t. Well, a negative answer doesn't make sense here, so we're going to take our 56 hundredths of a second is the amount of time it took for the book to reach the ground from a height of 5 feet. That is it for this lesson on perfect squares. Good luck.